Hey guys, this is lesson 4.6 for algebra. It's titled Absolute Values. Absolute value equations and inequalities. So it's kind of a tricky lesson. Now, first, what I want to show you is when you have an equation with an absolute value in it, you will end up with two answers. So watch, if I subtract 5 from both sides, I get the absolute value of x is 6. Now, the absolute value could be 6, so x could be 6, or x could be negative 6, because if I put negative 6 in, it becomes a positive 6, because it's the distance from 0 on a number line. Remember what absolute value is. It's distance, and distance is always positive. So, let's look at some examples. So try these in your notebook, and then we will go over them. Okay, so this one here, I'm going to add 2 to both sides. So then I get the absolute value of t equals 1. Now, the absolute value of t is 1, so that means t could be 1 or negative 1. You can write it with a comma, or you can write and, however you'd like to write it. I don't really care. So you divide both sides by 3, so the absolute value of n is 5. So my two answers, it would be n equals 5 or negative 5. And then lastly, I have this one. I'm going to add 2 to both sides. So then 6 equals 3 times the absolute value of w. Divide by 3. So the absolute value of w equals 2, which means w is 2 or negative 2. So is there a solution to 2 absolute value of n equals negative 15? So look at this. Now, if I divide both sides by 2, I get the absolute value of n equals negative 7.5. Is that possible? No, it is not possible, because you cannot have a negative inside here. Yeah, I could put a negative on the outside, but this does not have that. It asks what is on the inside. So that would be no solution for n. All right, next we have solving an absolute value equation. So what you end up having to do is solve 2 equations for each one. Now, if you notice here, this has the absolute value of 2p plus 5. It has more under or inside the absolute value marks, where these ones back here, they only had one thing inside the absolute value, like the n or the t or the w. This one, however, has 2 things inside, so you have to do more of a solving process. So if you look at what happened, they minus 5, and they got p equals 3. So let's check that. 2 times 3 is 6, plus 5 is 11, so that works. Now, could I just write negative 3 as my other answer? Well, let's check it. 2 times negative 3 is negative 6. Negative 6 plus 5 equals negative 1. That does not equal 11. So you cannot just write the negative answer. What you end up having to do is solve a whole nother equation with a negative 11. So notice the difference between these 2 equations. One is positive 11 and one is negative 11. When I go through and solve that, I can get my other answer, which is negative 8. So put that in. 2 times negative 8 is negative 16, plus 5 is negative 11, but it's the absolute value, so then it turns to a positive 11. So that's perfect. So try these 3 equations, and then we'll check. All right, here I'm going to add 2 to both sides, so then I get c equals 8. That's my first one. I rewrite it with my answer negative, so then I add 2 to both sides. My other answer would be c equals negative 4. Here I'm going to minus 2 from both sides. So then I get t equals negative 7.5. And then if I rewrite it, switching my sign of my answer, then that was negative, so I'm making it positive. I minus 2 from both sides, and I get my other answer of 3.5 equals t. And then lastly, if I divide by 7, I get d equals 2. And then if I rewrote this as d equals negative 14 and divide by 7, I get d equals negative 2. So look, you have to do each equation twice, changing the answer to a negative each time. So the same thing is true when you have an inequality with an absolute value sign. So I'll show you how to do this. You can write this down if you want, but I think it's kind of confusing. I just wanted you to see the rule so that you have it in your notes if you want it in your notes. But if not, we can just do the example and I can show you how to do this. So there's 2 different things you have to do. One, you have to solve this first equation. And then to change it, you have to change the answer, just like we did before, where we changed the answer and we made it back here, how we went from a positive 11 and then they changed the answer to a negative 11. So we have to change the answer, the sign. And secondly, you have to flip the sign. So I'll show you how you do this. So I have to solve this equation right here twice. So I have to do w plus 2, absolute value, is greater than 5. And I also need to do w plus 2, absolute value, is less than negative 5. So I do the exact equation, and then the second time I change the sign and from a negative to a positive. So if I do this, okay, I'm going to minus 2 from both sides, so then I get w is greater than 3. That's my first answer. Here I'm going to minus 2, so then I get w is less than negative 7. Second answer. When I go to graph this, I draw a number line. I do w is greater than 3. So I go to 3, I have an open circle, and it's everything greater than. And then w is less than negative 7. So then I go to negative 7, I have an open circle, and I have everything less than. Now, let's just check to make sure we did this correctly. Okay? So, let's pick 4, just as an example. Put it into the original equation, which is right here. 4 plus 2 is 6. Is 6, the absolute value of 6, greater than 5? Yes, so I know that works. Now let's pick 8. Negative 8, sorry. Negative 8 plus 2 is negative 6, but then I have my absolute value bar, so that becomes a positive 6. Is that greater than 5? Yes, so that works too. So both of these work, and you're going to end up with a graph like this where you have 2 things going either in opposite directions or they could go in the same direction. All right, lastly, we have the ideal diameter of a piston for one type of car engine is 90 millimeters. The actual diameter can vary by 0.008. Find the range of acceptable diameters for the pistons. So this looks kind of confusing, but what they did is they did an equation. The diameter minus 90, absolute value, has to be less than or equal to 0.008. Then what they did is they solved it twice. So, and you can kind of see that here, but they kind of tried to put it all into one big, huge equation. So let me show you with another example. So it says the ideal weight of one type of model airplane engine is 33.86 ounces. The actual weight may vary from the ideal by 0.05 ounces. Find the range. So what you do is you have your engine and you want it to be, now do you want it to be greater than or less than? Well, it says the ideal weight. So I'm going to be, no, sorry, E minus 33.86. So I'm just kind of comparing this to this equation here, and then that becomes absolute value, has to be less than or equal to 0.05. Now that's the first equation. Now I have to solve two equations, remember, so I'm going to have E minus 33.86 is greater than or equal to negative 0.05. Remember, I have to change my inequality sign and I have to add a negative. So I have my two equations. I'm going to solve them. I'm going to add 33.86 to both sides. So my engine for the first one has to be less than or equal to 33.91. And then for the second one, I am going to add 33.86 to both sides, and that's a negative 0.05. So E has to be greater than or equal to 33.81. Now I have two equations. So what I do is I draw my number line, okay, and I go to 33.91. I have a filled in circle, and it has to be everything less than. And then I go to 33.81. I have a filled in circle, and this is everything greater than. So here is an instance where it's everything in between is okay for that engine. Any number in between is okay for that engine. And notice, the ideal is 33.86, which is right in the middle, 33.86. This is plus 0.05 and this is minus 0.05. So if you're in manufacturing, you could be up a fifth, 5/100ths of a centimeter, or down 5/100ths of an ounce. So that is it for your notes.